In this lesson, you're going to learn about volume. So we're going to start off with finding volume of prisms and cylinders. So first of all, volume is the space that a figure occupies. So it's how much space is in something. And when we measure volume in cubic units. So it's because there's 3 dimensions here. You're multiplying a dimension by a dimension by a dimension. So units times units times units is going to give you units cubed. So you'll see it written like this with the units cubed. And then this first part here is talking about a formula that you guys have seen a lot in elementary and middle school. The volume is length times width times height. This only works for a rectangular prism. And really, in high school geometry, we're going to look at other figures, not just rectangular prisms, any kind of different prisms. So you really have to think about, well, what does this really mean? This formula really is the same thing as saying the area of the base. So my bases are the length, are rectangles. So if I looked at these two as my bases, the area of those would be length times width, and then the height is the distance between the 2 bases. You then multiply by the height. So really, when we think volume, length times width times height is really saying the area of the base times the height. That's another way of thinking of it. So in geometry, that's how we're going to view it. It's of any prism, it's the area of the base times the height. And I know it says it right here, the area of the base, B, and the height. But I'm also going to write a note that capital B stands for the area of the base. Lowercase b would be a length or the dimension for the base. But when we're talking about a capital B, it means the area. Same thing, anytime you use a capital letter in math in a formula, like volume, capital V, perimeter, capital P, area, capital A, it means there's a calculation involved. So just kind of use that to help remind you. So it's the area of the base times the height. So if for any prism, so volume of prisms will be the area of the base times the height. So again, I'm just going to write that underneath. And then we can also use this idea to help us with cylinders. So when you think about a cylinder, you have 2 circular bases, volume of cylinders. So you end up with 2 circular bases, and you still need to know the height of the object. So the height is the perpendicular distance between the 2 bases. So when we think about our formula, you're going to do the area of the base, which is a circle, so it'll always be pi r squared, times the height. So it really comes from this same formula. The reason for prisms, we say area of the base and we keep it with a capital B and we don't plug in a formula, is because any polygon could be the base, so then the formula for area will change. So that's why we don't want to just plug in length and width, because it's not always going to be a rectangular prism. So let's look at these examples. This first one, you see this, it's a common design for swimming pools. So if you think about this as a pool, because you have a shallow one and a deep end, this is a common idea here. So if we wanted to find the volume of this pool, we need to think about, well, what kind of shape are my bases? So this is the prism, and if you look at these bases, so I'm going to go ahead and highlight the bases. So I have a base here and the same shape in the back. My bases are actually trapezoids. So this is a trapezoidal prism is what you would call it. And what I'm going to do is I'm just going to redraw that base in the front. So here's my trapezoid, here's my parallel sides. So this is 10 feet. I know that this dimension right here would have to be the same as what's in the back, so that's going to be 4 feet. And I know right here and in the front, that's 30 feet. So since this is a trapezoidal prism, when I go to use my volume formula, it's the area of the base times the height. Well, the area of the base is actually a trapezoid. So I'm going to say area of trapezoid. So that means off to the side here, let's figure out that first before we plug in. So area of the trapezoid is equal to 1/2 base 1 plus base 2 times the height, or base 1 plus base 2 times height all over 2. So this area, when we go to plug in, will be 1/2. My bases are the parallel pieces. So I'm going to plug in. I have 4 plus 10, and the height's the distance between those, so the height's 30. So go ahead and plug that all in. So we have 4 plus 10, so we have 14 times 30, and then divide that by 2. So we get 210 for that. And this is going to be feet squared, our units, because we're talking about area. And then from there, once I know that that's 210 square feet, now I need to find the volume. So my second step is going to be to find the volume. So that is where I'm going to use my formula, area of the base times the height, and I'm going to plug in this area in for B. So it's going to be 210 feet squared times the height. The height is the distance, remember, between the two bases. So even though it's not standing perpendicular to the ground, the height is always the distance between those two parallel bases. So it's going to be times 15. So 210 times 15 feet is going to give me 3,150 cubic feet. And there's our volume. So this is the volume of the pool, or how much water it can hold. It can hold 3,150 cubic feet of water. So that's a little bit more complicated, in my opinion, than cylinders, because cylinders will always be the same base, or a rectangular prism, always the same base. But you have to be careful because you could really have any polygon for a base. So looking at number 2, this time it tells us we have a cylinder. So we have a cylinder, so let me just sketch a picture so we're looking at this. And we have a height, so that perpendicular distance of this is going to be 8 centimeters. We know that the volume is 402.1 cubic centimeters. We want to find the radius. So this time we're not trying to find a volume, we're trying to find the radius. But I do know the volume, and I know the height, so I'm going to use the volume formula. So volume is going to be the area of the base, so pi r squared times the height. So plug in, so pi r, plug in for volume, 402.1, pi r squared, and then my height I do know. So I need to get r by itself, so that means I need to divide both sides by 8 pi. When you divide by 8 pi in your calculator, you either need to do it in 2 separate steps. You need to do it as a decimal, or you need to put it in parentheses. If you just do 402.1 divided by 8 pi, not in parentheses, what your calculator is going to think, I'm going to erase this, but what your calculator is going to think is that you want to divide by 8 and then multiply by pi. So make sure that you're telling your calculator, no, I want that entire 8 pi to be on the bottom. Make sure, too, when you're in your calculator that you see that. So 402.1 divided by, in parentheses, 8 pi. And that's going to give me r squared is equal to 15.9991. And again, I'm not going to round until the very end. And now I want to square root both sides. So square root it. Remember, arrow up to select that number. So you're using that exact number. And I'm getting r equals 3.99988. So it doesn't say what to round to for the radius. I'm just going to round to the nearest whole number. So let's just say round to nearest integer. So that means the radius is going to be approximately 4 centimeters. Notice my units are just centimeters here because I'm talking about a dimension. I'm not talking about an area or a volume. So that's it. So go ahead and get some key ideas written down from the video that you want to remember. Do your check your understanding problems, and we're going to do more with these kinds of examples in class tomorrow.